So this is a little demo on checking the assumption of normality. So I hope that you'll be able to orient to this data set that I'm working with. First off, I have a data set right here, of 20 individuals, and they all produced scores on a certain test. And these are the list of their scores. And you can see that I have rearranged all of these individuals so that their scores are ranked from the lowest score of 81 to the highest score of 130. And so you can see the individuals are now out of order. You can also see that I've gone ahead and done all the calculations so that we have the mean given of this data set, the number in the sample, degrees of freedom, sum of squares, all the calculations we need. We end up with a t-sample score of 1.97 and an effect size of 0.43, so a moderate effect size with a result that was significant. So what we're going to do now is we're going to check to see if these data were actually normal, if we actually met the assumptions of the independent samples t-test. And so I'm going to just show you how this is done in Excel, but we're not actually ourselves going to do it in Excel. So I'm going to just unhide the work I've done. So first of all, what we do to figure out to make our QQ plot is the first thing we need to do. So let me just write that down here. And I'm going to show you how to do it by hand, but then we'll actually just use a tool to do it. But I think it's important to understand it. So our step one is the QQ plot. And it's plotting quantiles, and you'll recall that the quantiles are just like percentiles. They're just telling you if this was normally distributed and we had 20 individuals in our sample or 21 individuals in our sample, the lowest score would be in what quantile or what percentile is another way to think about it. And you can see here that about 2.3% of the scores would be below this lowest score of 81, which is just what we would expect in a normal distribution. Think back to the 50-34-14 rule, and that's where these quantiles are coming from. So you could think of them like percents. We could even, shorten them so that they look more normal. But you can see that right in the middle, well, about 50%, about half of the scores would be below this score that's right in the middle. And that's what this 0.5 represents. And you can see here that this is the t-value of expected scores. So if someone was in this 2% quantile way in the bottom of the distribution, we would expect them to have a t-score of minus 1.98. If someone was right in the middle of that distribution, we would expect their score to be 0. We know 0 is right in the middle of the z distribution and the t distribution. And if someone was way up here, this highest score, they would have a t-score of 1.98, and they would be in the 98th percentile, the 97.6th percentile. So that's what these represent. And then we did one more formula to calculate the raw score that we would expect relative to all of these calculations. So someone with an expected t-score of minus 1.98, when I do the calculation, they would have a raw score of 78. We can see the actual score was 81. If we come down here, we can see that for the next one in line, the next ranked person, we would expect them to have a score of 104 if the distribution is normal, and they actually have a score of 105. I feel like I should freeze these. I'm just going to freeze the pane here so that we don't keep losing our headings on the columns. Now we'll keep those headings on top. If we go down here, this person at the higher end of the distribution with 121, an actual score of 121, they're in the 78th percentile, so to speak. Their t-score would be expected to be 0.79, and that comes to a raw score of 117 that we would have predicted. Our highest person should have had a 134 if it was a really normal distribution, but they had a 130. So let's go ahead, and the first thing we're going to do is we're just going to look at the histogram. So I'm just going to select all of these and cross my fingers that everything goes swimmingly here, and we can get a histogram. Okay, and as you probably also had this experience with histogram, let me unfreeze the panes now, I guess. I want to get my whole screen up here and I want to just collapse this toolbar quickly. There we go. Give us a little more room. Now, I'm not in love with this histogram. I want to change the number of bins so I can actually see something that's going on in it. So I'm just going to do this to demonstrate for you. Just going to make, more bins. Let's make, say, 10 bins, and then we'll be able to actually see whether it looks kind of normal or not. So we can see here, this is the question, is this normal enough? It doesn't look normal. We don't have more than 30 and we don't know about the population. So this is when we test ourselves to see, okay, is this actually normal or is it something that violates the assumptions of our statistical test? So that's what we have for our histogram. Let's move this out of the way and just drag it out of the way now and get rid of our image if we can. Just get it down there at least. There we go. And now we're going to go ahead and I'll show you how we make this QQ plot that was described in the lecture. I'm going to select these two columns of data. Whoops, I forgot to hold my control key down for selecting non-contiguous rows. So let me do that again, this time holding my control key down. Now I've selected these two rows and I'm going to go back to my insert menu and I'm going to choose a scatter plot. And then I'll show you what that means. So this is our scatter plot. I need to just, in order for this demonstration to look right, I just want to get rid of these lower scores. I'm going to start our scatter plot at 80, our lowest score. And I'm going to do the same over on this other axis. And this is not something you have to worry about because you're going to be doing this all automatically, but it's going to help you a lot if you know what this is actually meaning. So let me just change this one also. If I can. There we go. Format the axis and also start this one at 80 because a QQ plot generally goes from corner to corner. So this is what we want it to look like. Let's add a line now. Let's go to our data and add a line. And now we see that straight line. So this is what that QQ plot looks like. So what's it showing us? It's showing us the actual scores compared to the predicted scores. Now, when I look at this, it doesn't look too bad, but we have a little bit of muddiness, a possible outlier right here as this tail veers away from the rest of the data set. Okay, so that's the QQ plot that I generated in this quick example. I'm going to run the skew test and I'm going to run the kurtosis test, and then we'll get our Shapiro-Wilk statistic. So the formula is so simple, equals skew, and we'll just select our data. And we have a minus 0.11. And remember, 0 means we have a normal distribution. So that doesn't seem too bad to me. We want scores that are closer to 0, and this seems pretty good. Our rule of thumb, if you'll recall, is, I'll pull it over so you can remember it from the lecture. Our rule of thumb was that if it was 0.5, less than 0.5, it's normal enough. So I'm thinking that that skew isn't going to matter. But let's check for kurtosis too. The formula is so simple, equals kurtosis. We'll once again select our data. And we can see we have a minus 0.74. Now, remember, scores close to 0 are good. The skew distribution is a smaller distribution. The one for kurtosis has a little bit bigger range. The scores can get higher. So anything less than 1, it's pretty tiny here, but anything less than 1 is close to normal. So it's looking to me like our data are okay. But let's go ahead and get the Shapiro-Wilk statistic, and the link will be posted for you as well. I'm going to pull it right out of the slide here. And so we're going to go to this site right here. I already have this open. And when you get there, what you're going to do is put your data in. So what I've done right now in the background is I've just copied the raw scores. This is the site that we're going to come to. Oopsie. This is the site that you're going to come to, and you'll scroll down to this calculator tool and you'll click on this link where it says paste upload data. I've already copied my data, so I'm just going to use Control V to paste it in. Let me see here if I can get this to paste properly. I did it earlier, so I should be able to do it again. There we go. So we're just going to cover up all this stuff, and I'm going to unclick my data has header because all I copied was the data. The header would be like the heading of the column, and I just paste my data in there. So you can see that I got rid of everything that was there. I unchecked my data has header, and now I'm going to go ahead and calculate. Whoops. Okay, that's not the right button to push. I've used this a few times, but here's our data, and let's see if there's something hiding at the bottom. I'm just going to pull it onto a bigger screen because I think the main button is hiding at the bottom. And there we go. We have to just get to this button that says import data at the bottom. And I have to get to it on my other screen. So if you're doing this on your own screen, you're going to need to click on a blue button at the bottom of your data that says import data. It wouldn't show up on my screen for just because of my screen settings, presumably. Now our data are all here, and we can go ahead and look at our QQ plot. It's telling you how to interpret it. And let's see if we actually can get our QQ plot. And kind of scroll down quite a bit, and then we come to where it is. And oh boy, is this our actual one? No, that's a sample data. Okay, so I am going to, there it is, generate QQ plot. Sorry that took me so long. Please select the data column, generate QQ plot. I'm going to select these data, the only data that are there. A little bit tedious here. So now I've placed my cursor on the top one. I'm holding the shift button while I select the bottom one. Let's see if I can get it to select this column of data. I'm not sure if it's selected it yet, but let's see. Select a numeric column, column 1. There we go. Generate QQ plot. All right, so then we'll find our results. Our results look fairly similar to what we had before. We can see a little bit of divergence at the bottom, at the top of the distribution, so it's not too dissimilar from what we did on our own. And now we'll see this test statistic, and we can see a couple of things here. So first off, the Shapiro-Wilk test gives us a statistic of 0.97. You might recall that for this test, we want to be close to 1. And this is really close to 1. They said we might need to worry if we get a statistic lower than 0.9, but we have a nice statistic that's at 0.9. And so let me put that into our spreadsheet. And then the second thing we have is the p-value. So the Shapiro-Wilk. It was that 0.9712. Let me just paste it so it doesn't change all our formatting. And then the p-value, the significance level, let's go back and look at that. Remember, in order for it to be significant, we need it to be less than 0.05. Here, our p-value is 0.76, so it's way, way above 0.05. What that means is our data are not significantly different. It means that we fail to reject HO. We have this significance level of 0.76. It would have to be less than 0.05 in order to reject the null. Failing to reject HO in this case is a good thing because it means that if we interpret it, our data set does not differ significantly from a normal distribution. And that's exactly what we want. We could put our statistical test, we could put W. Let's just put W equals 0.97, P, and I'll just put the equals 0.72. So all of our tests are showing that our distribution is normal and can be used for analysis. And so this is how we would go about and test for normality. I'll probably do another demonstration of the QQ plot generator, just because that one was a little awkward when I tried to show you the tool. But other than that, this is good to go. You should be in good shape for working toward this one assumption, testing for normality on your own, and you'll get something like this.